Hello, everyone. So in this video, I want to go over linked list. We'll do a lot of examples with the linked list. And what we're going to do is we're going to create linked list class. So we're going to create that data structure. So you'll see what actually happens in the back when you actually start using it. So if you wanted to learn about, if you just wanted to use the built-in linked list class that Java has, you can do that. That's easy. You can declare the data structure and you start adding stuff to it. So you can do add function, and let's say you wanted to add a bunch of names to it, and you can do that. You can use that linked list class. Remember this right here. This is where you actually define which data type you're going to be storing in the linked list. So here I have strings. I have to store strings, and if I have integers or any other data type I want to store, I have to define it here, right? What we're going to do, this is easy. They have add functions. I'm pretty sure you went over stack and queue. It pretty much works the same way. What linked list is, let me bring out the pen. So linked list is essentially nodes, right? They have nodes, their value. So this would, let's say this has a value of 3, and they're linked together just like this. So this has a value of 4, and you keep moving, and that would be whatever the value is. Let's say it's 10, and the last node is a null, right? And you have a pointer pointing to the list. Right now you have this list. So list is pointing to the first element right here, and that actually they're just chained together. So each one of this, so this right here, this is a node. This is known as a node, and node has a value and a pointer pointing to the next node. Then the next node has a value and a pointer pointing to the next node. If there is no next node, that pointer is null, right? So that's how the linked list is actually working in the background. So once you declare it this way. So right now I have numbers in there. If I have strings, that data value will be strings. So what we're going to do is we're going to create that node class, and we're going to create that linked list class, this one. And we're going to see how that's going to work in the background. Okay, so let me clear this out. So if you go over the slides, and if you go over all the material, this is where it should be leading you to. So if you're watching this video without reading the slides or the material that I've posted, make sure you go read that first, and then you come in here and we can go and create this class. Otherwise, you may get confused. All right. What else? Okay. So linked list class exists in Java. We're not going to use that. We're going to create our own class. So the class we're going to create is going to be linked int list. So linked int list, it's only going to be for integers. We're only going to store integers in there, and it's going to be linked int list, right? And we're going to design it exactly well, not exactly, but similar to what Java has done it in the background. Okay. So the first thing we need to add this class to our project. So what we're going to do is add a Java class, and we're going to be linked int list class, just like this, and that's going to be the data structure we're going to be using. And remember, the fields, first thing we need to define fields. Remember, in the linked list, they're chained together, right? So we need, what is chained together? So where's the pen again? So there's nodes, they're chained together, right? So this is the data. We'll add the data and then the pointer to the next one. So that's what we need. We need this node. So node is the field for linked list class. So that's what we're going to define here. We're going to define private node, and that's going to be, we're going to call this the head. Head means it's going to be the first element. And we don't have that node class right now. So we can go and add that. So we're going to add a new class called node. And that node class, so this is the node right here, right? So linked list is a bunch of these linked together is a list. Each one separately is just a node. So what goes inside the node is the data and the pointer to the next list. So here what we're going to do is the fields, or if you're calling it attributes for this class, we're going to have private, we're going to have node, just like this one. And what else do we need? We need, I'm sorry, we don't need, first thing we need is the data. So remember, we're going to be using this for integer. So this is going to be an integer, and that's going to be the data, right? And the next thing we need is, still going to be private, and we're going to call that node. And that's the next pointer. That's the next pointer pointing to a node. Remember, this is an object, right? Remember, when you try to print an object and it doesn't have a toString method, if you try to print it just like this, it prints the memory address, right? So that's what this is holding right now. The pointer is holding the memory address to the next location. Okay, so that's what we have. And we need a constructor. So I'm actually going to generate that. So right click anywhere inside the class. I'm going to generate the constructor. And constructor is going to take both of those two parameters. I'm going to click OK. And if you want, you can generate getters and setters method. It's up to you. I can go and do that, but I don't think we're going to be using that in this class. But they're there if we need it. Okay. So main thing we need is the constructor to declare, create a node. Okay. So now if you come in here, that red line is gone. We have a node, and that's the head. The reason I called it a head, remember, all the linked list is a pointer to the first node, and pointer to the first node, and that would be the head. And the last could be, it is also known as a tail. So so we need to pointer to the first element, and that is it. If you don't want to call it head, you can call it first. That would be okay too. But I'll leave it as it is for right now. All right. What else? What else? What else? All right. We can also have another field. So we can have integer, and we can keep track of the size. Remember, linked list does not have indexes, right? So it doesn't have indexes, and there's no way to print something from the middle. We have to go through the whole list or up to that list to print it. And we can keep track of the size. Then if somebody needs the size, we actually don't have to go through the whole list. We can just print the size as it is. So every time we add something to the list, we increment the size. And this is obviously optional. If you want that functionality in the linked list, you can add that. Otherwise, that is it. We have the linked list, and then we have the node. And this actually doesn't have constructor. If you wanted to, we can add the constructor in there. So what would that constructor look like if we have a constructor for this? Excuse me. So what would that constructor look like? Or do we actually need a constructor? So let's try to declare a linked list and see if it's going to ask us or not linked list. We're going to create our own list equals to new linked int, just like this. So there's a default constructor that's already built by Java. Any object that you create, it doesn't take any parameters, and we don't need to add any parameters, right? So we're going to be adding stuff to this list by using the add function. So if you do list.add, obviously it doesn't exist because we don't have any functionality for this list. You can go ahead and add that add function in there. So the first thing we're going to do is we're going to add public void, call that add function, and the add function is going to take the value or the data from the user and create a list, right? So the first, this add function is going to be divided into two parts. The first part, what happens when you create a list and it's the first element, right? If it's the first element, and then what happens? It's the second element or after, right? So if it's the first element, all we have right now is a head pointer. So if you declare the linked list just like this, what we have right here, I'm going to delete this just right here. So all this did was We have a head, and that is pointing to null. So head is pointing to null. Where is head coming from? Head is right here, and that is pointing to null because it is not initialized. And if it's the first element, what should we do? We should point this head to the first element, right? So what should happen with first element the user try to add? We should do create a node. First, we should create a node, add this value in. So whatever that value coming in is, let's say it's 7, set this to null, and change this pointer and point over here, right? So now we have a list with one element. So this null is gone. That's what we should do for the first element. So how do we know it's the first element? We can check if the head is equals null. If head equals null, that means it's the first element, right? Because head is not pointing to anything, so that means this must be the first element. If it is the first element, what should we do? We need to create a node. So node node equals to new node, creating a node. And remember that node is coming from here, and we need to use this constructor to create it. It takes in the data and the next pointer. Remember, we create the first element using the data, and the next pointer will be pointing to null. So we pass in the data. Data in this case is the value that's coming in, and then is pointing to null. All we do is head equals to the node. If you want, we can. If you just node is confusing, you can do new node, and that's a new node we're creating. So we can do something else. Right. So next, else, if head is not null, that means we have the second element or third or fourth or something like this, right? And how do we know how many more elements we need to go through? Let's say we have head, then head is pointing to another element, and that is pointing to another element. How do we know we're all the way at the end? Because remember, we have to add it all the way at the end. We're not adding anywhere in the middle, right? We have to go through the whole list, find, I'm gonna add 1, 2 here. Right. We need to find when this is null. We need to find a null here, pointer here. And to do that, what we can do, we can run a while loop. So else in the else part, what we can do, while this is null. So I'm going to actually write it cleaner. So I'm going to raise this a little bit. I'm going on the side. All right. So now what we have in this line 11 through 13, we don't know how many elements we have. We need to go through the whole list, and let's say it has 3 elements and it looks something like this. So this is 3 that is pointing to the next node, and that is, let's say, 15, and that is pointing to the next node. Let's say that is 10 value, and then this is null, right? So now let's say the list looks like this. It'll fall into the else part. How do we know we're all the way at the end? We can move this. We can have a pointer that moves along in the list and checks if this is null or not. We cannot change this pointer. The reason we cannot change the head pointer is as soon as you change this pointer point to something else like 15, then the 3 is gone. There's no way to get back to 3. The only way we know where 3 is because head is pointing to it right now. We have a memory address saved in the head variable that tells us where the list starts. If we change this, we don't know where it's going to be. So what we can do is we can create a copy of the head pointer. So what we can do, we can create a current pointer, and we can point that here, and then we can move that along the list. And doesn't matter if you change this pointer, this is a temporary pointer, head will always be pointing to the first element. So here, what we're going to do is we're going to make a copy of the head. So we're going to do node current equals to the head, just like this. And here we can do current dot next. One thing I did was I'm not able to access the next element here. The reason I'm not able to do that because I've set this to private. I'm going to change this to not private, so I can actually use these in my class. Here, the other thing you can do is you can make this node class inner class of linked list, and then you don't have that problem anymore. And you can, if it's the inner class here, then you don't have to worry about the private or public. Right. All right. So keep running the loop until you get to the null. Okay. And inside the loop, what we're going to do is current equals to current dot next. So what's going to happen here is current is pointing here. What we're going to do is current. We don't want you to point here. We want you to point to current dot next. Remember, this is current dot next would be this pointer. So wherever this pointer is pointing to, go ahead and point to the same thing. Then when we get here, we check current dot next. Current is pointing here. We're going to say current dot next. If this is not null, right, we're going to go ahead and say move the pointer this right here. And then we're going to check again current dot next, which is current dot next, this one. If this is not null, in this case it is null, then we're going to get out of the while loop, and then at the end the current will be pointing right here. Okay. And then when we get out of the while loop, that means we are all the way at the end, and we can do current dot next equals to the new node. We don't have the new node, so I declared it inside the if statement just one time. So either way, we need to create a new node. So I'm going to move this outside right here, so I have access in the both places. So what this is going to do, we're going to get all the way at the end, and this line right here, we're going to say current dot next. So this pointer right here, we're going to assign. Remember, this is an assignment, right? So we're assigning a new node. We're going to create a new node right here with the new value. Assign it here, just like this, and set this to null. That null, this null right here. So we're going to add it all the way at the end. All right. Then remember, we're adding a new node here. We're adding a new node here. Size in Java is default to 0. Anytime it's not initialized, its default is 0 in Java. What we can do is we can do size plus plus. We added something to the list. Now the size is incremented. Right. And so what we can do is we need to test this out if this is working or not. I'm going to delete this, getting kind of messy. And to test this out if this is working or not, we can write a toString method for this, and then it'll tell us if this is working or not. Right. So I'm going to add a toString method here, and is it possible to generate it? Let's see. What is it going to give us? I'm going to click OK. And it's linked list head. I don't want this print, this kind of linked list printed. I want what I showed you. You have a value pointing to the next value, pointing to the next value. We can actually create that, right? So we can actually do toString right here. And what we're going to do is we're going to do string result equals 2. We're going to start this with head, and that is pointing to something, right? And then what we can do is we can copy. Remember, to print that list, we have to go through the whole list to print it out, right? And that's exactly what we're going to do. So we need current, or if you want to call it front or anything, we just need a copy of the head. So we're going to make a copy of the head, and we're going to get rid of this so there's no confusion. Copy of the head, and then I'm going to have a while loop. Every time you need to go through the list, linked list, you're going to need same thing we had above. this while loop to go through the whole list. I'm going to copy that, paste it in there. Current is not null. Keep moving the pointer forward. And inside the loop, what we're going to do is we're going to attach each element to the result. So we're going to do result plus equals to front, and what front? Current dot data. And that's going to be plus string, something like this, right? So keep printing it this way. And when we get at the end, remember that we still need to print one more. And we can print one more all the way at the end. So we can do results. So we're trying to build a string this way. So we're going to do current. I think that's it. Because right now, what we can do here is last one is going to be pointing to null. We can actually define it here as well. And so we started with the result in the while loop. Excuse me. In the while loop, we're adding each element one at a time to the string builder. And then we're going to return the result. That's going to print the whole list out. We can test it out. We have the list created. I can do system.out.println, and then excuse me. Let's see. I think I'm going to get an error. So I'm trying to print an empty list. So I can do toString like this, or I can just call it like this. It's going to go in and try to find the toString method automatically. So I think I'm going to get an error. Let's see what's going to happen. Yeah, so the reason I'm getting an error is, I think the reason I'm getting an error, I'm trying to access something here. And that is null, I think, and not field next, because the current is null. Yeah. So I'm not, so we can have if statement here. So we can do if head equals null. That means the whole list is null. And we just return head is pointing to null. If it's an empty list, we just return. We don't even execute the result, code below that. We just say we don't have anything to print. So run it now. That should go away. All right. Head is null. Head is pointing to null. Right. So now let's go and add stuff to it. So we do list.add. We have a list.add function now. Let's add the 7. Oops. List.add 10. Actually, let's do 1 and let's see how that's going to work. Run it. So head node, and then that's pointing to null. So let's see, why is it printing the memory address, not the data itself? We need, oh wait, where is this coming from? Oh, this right here. So we need current.data. So I'm printing the whole node. The node class doesn't have a toString method here, so it doesn't know how to print that. So I need to change this to data. I'm printing the data itself. Run it again. All right, so now we have head pointing to 7. 7 is pointing to null. Okay. Now we do list dot add. Let's add 10 and add more things. 13 and let's say 1. Run it again. And my head pointing to 7. 7 is pointing to 10. 10 is pointing to 13. 13 is pointing to 1. And then 1 is pointing to null. Okay. And there's a lot of space in here. I want to get rid of the extra space. Get rid of it here. Get rid of it here. This one too. This one too. Rerun it and see what happens. All right. So yep, that's the list. One cool thing. Let's see. Do we have time for something else? Yeah. Let's see. What else can we add? What else can we add? Let's do contains method. But before we get to contains method, I want to show you something really cool. So I've been drawing it on the screen and showing you, but you're gonna have IntelliJ actually show you that. So there is a plugin, JGrasp. So you can add a plugin to IntelliJ. I'll show you towards the end how to add that in there, and then it'll give you this canvas screen, right? And this canvas screen will visualize the linked list, how it's moving. So I added a breakpoint here, right here, and I'm gonna debug it. So I'm not gonna play it, I'm gonna debug it. And as soon as it hits this breaking point, it's gonna stop here. And what I'm gonna do is I'm gonna drag this to visualize it. All right. So right now we have a head pointer and the size is set to 0. Let's see what we execute line 7, what's going to happen. So I'm going to do step into. It's going to go into node class. It's going to declare this. It's going to do it step by step. And it's going to go into the add method. I'm going to move this towards a little down. So it's creating a new node. And if the head is null, there you go. I'll make this a little bigger. That new node is pointing to 7. And the head is pointing to 7 now. So keep stepping through it. And the size incremented right here by 1, the size is 1 now. And let's look at it one more time. So we just added 7. So this is what happened. So pointers, how pointers are changing, you can actually visualize it here. Make this a little bigger. Step into again. Go into node class, declare all the things we need to. Then when we create a new node, it creates a new node. This is what we were missing. I had it really small. So this is, we create a new node, and the new node, that the square right here, that means it's null, and we have a value of 10. Good. And we're just going step by step. And then we have current pointing to head right here. Current pointing to head. We have current pointer pointing to head. And then we're going to execute this one. We're going to say current.next equals to null, equals to new node. And that is exactly what happened here. At the end, when we get out of it, we have new node pointing to 10. But that doesn't matter. We only care about the head. Head is pointing to the first element, and that first element is pointing to the second one. That increments the size, and we move on. If you keep going, keep pressing it, it's going to create the list in front of you. And just like this, it's going to create the list. Just like that. And the size is incremented to 4. Okay. All right. So I did say we're going to add the contains method. Let's go ahead and add that. So I'm going to close this. Edit discards. I'm not going to save anything. Stop it. And then what we're going to do is we're going to add contains method here. So right below add, I'm going to add a contains method. And contains method, what that's going to do is, let's go and write it. Public Boolean contains, and this is going to be, the user is going to pass in an element, and we're going to return if the element exists or not. So what we're going to do is, sorry. The element is param. This is return Boolean. And this is going to be true or false if the element exists in the list or not. Something like this. And checks if the element exists in the list or not. Something like that, right? Obviously, you can make this better, but for simplicity, I'm just going to leave it as it is. And this right here, what we're going to do is we're going to still divide that up into two parts. First element, sorry, we're going to divide that into if the list doesn't have anything, right? So no elements in the list. What we're going to do, we're going to do head equals null. If that is the case, we're going to return false because the element they're looking for doesn't exist because there are no elements in the list. The next case would be everything else. And first thing we're going to do is copy the head pointer. And that is the node current. So it's going to look similar to the add function. So we're going to copy the head just like this. We're going to go through the whole list like we're doing here. So I can even copy this whole and paste it here. Go through the whole list. And while we're going through the whole list, what we're going to do is we're going to check. So I'm going to comment this out too. So while loop to get through the list, right? And then inside it, we're going to check if the data is equals to the element. So remember, inside the while loop, we have access to the element to each node one at a time, and we can compare that to the element that's coming in. So remember, this is the data that they're passing in. So element equals come on, equals the data. They're not passing in the node itself, they're passing in the data that they're looking for. So we can have a check, we can do if current dot data equals the element. If that is the case, what we're going to do is we're going to return true. As soon as we find it, we're going to return true. And this just incrementing current pointer to the next pointer. And remember, just like this one, we need to check for the last one. Remember, when we get out of it, it is when we get out of the while loop, it's pointing to the the last element. Last thing we do when we get out of it. So this is what happens. Well, actually, I'll show you what's happening right now. We're not checking for the last one right now. So I'm going to shorten the list. So we only have to go through it 2 times. I'm going to debug it. And I don't even have the contains method. But let's do contains method, and then I'm going to do break. Not here. List dot contains, and we're going to do contains 13. 13 doesn't exist, but we still have to go through the whole list. And I'm going to add 13 here. Sorry. We'll change this to 12. Sorry. So 7, 10, 12, and we're looking for 13. So when we get out of the list, the current pointer is going to be pointing here. Or when we check for the contains, that's where it's going to be pointing to. So we're actually never going to get to the end. And arraign it without it's complaining because I do not have a return. I'm going to say return false. We'll open up the visualization part. I'm going to move the list here. And that's the list right now. And then I'm going to step into it and we're going to see how the contains method is working. So now We have head equals null. That is not the case. We go into the else part. Else part is telling you we're going to make a copy of a head into current. And that's what we just did. And then we're going to move along, check the data, move along, check the data. So this is where we're moving along. And now we're going to check the data. We're going to checking 10 against 13. That doesn't exist. That's not the same. So we're going to move the pointer to the next one right here. And then we check the while loop one more time. And in this case, current, which is current dot next, it is null. We jump out of it. We never check the 12. We never do go here. So I'm going to do step into, and you'll see we go outside the while loop. So we need a condition to check the last one. All right. So the condition to check the last one, we can add it here. Last element, and we can do if current dot data equals element. There are multiple ways to do it. So if you have a better way or a different way of doing this, and you don't need this extra condition all the way at the end, that's perfect. And as soon as you find that, we return true. And all the way at the end, remember, when you do return, we don't execute any code afterwards in the function, right? So when we get to this point, line 49, that means we didn't find anything equals to the element. This return true didn't get executed. This return true didn't get executed. So that means element does not exist in the list. Okay. And we just return false, and we're all done. And so I'm going to put this in system.out.println, and we're going to print true or false. Run it. Excuse me. And that returns false because 13 doesn't exist. I'm going to get rid of this too, and I'm going to change this to 13, and now we should get true. True, because 13 does exist. All right. Perfect. Any questions? Well, if you do have questions, please let me know. I do want to show you how to add that plugin for JGrass. So what I'm going to do is I'm pretty sure there are multiple ways you can do this. The way I found it was through the main page. So I'm going to do is close project, and I need to share my screen again. Sorry about that. And I'm going to share my screen again. This is the screen right here, and I'm going to go into plugins, and this is where you search for JGrass right here. JGrass right now I already have installed, but if you don't have it installed, you should have a button here that gets installed. You install it, and that is available to create a new project and then do what I just did, and you should have that available. All right. There are a bunch of other things you can do with that, very cool stuff. So yeah, it is very useful to have that available. If you have any questions, always email me. Let me know. If you need help, stop by during my office hours. See you guys later.